This is section 10.4, use square roots to solve quadratic equations. So remember, so far we know how to factor to solve, and we know how to graph a quadratic equation to solve. So this is another algebraic approach for solving quadratic equations. Okay, so let's remind ourselves how square roots work. If we take the square root of 49, remember technically there are two answers that would give us 49. 7 squared and negative 7 squared. So if it doesn't specify, it's actually asking for both answers, positive 7 and negative 7. Notice this one has a negative sign out front, so that tells us that it's asking for negative 7. For the square root of 121, well, square root of 121 is 11, but in this case, we want the positive and the negative answer. So the square root of 121 is positive 11 and negative 11. This last example, the square root of a negative number is going to give us a non-real answer. It's going to give us an imaginary solution. So for our purposes, when we take the square root of a negative number, we're just going to say no solution. Now, we can also take the square root of a variable. So if we have x squared and we take the square root of that, it's just going to be x. Okay, but think about it. Just like the square root of 49 is the square root of 7 squared, and we get 7, okay, because we can rewrite 49 as 7 squared, it works the same way. So if we take the square root of a variable squared, we're essentially undoing the square by taking the square root. Okay, so we can use this to help us solve these quadratic equations. So, especially when there's no middle term, that's when taking the square root is really a good option. So here, in order to take the square root of x squared, I need to get it by itself first. So I'm going to divide by 2 on both sides. I get x squared equals 8 divided by 2 is 4. And now, to get just x by itself, I have to undo the x squared by taking the square root. Square root of x squared is x. And remember, the square root of 4 is both positive 2 and negative 2. Okay, so if we were to graph this, we'd have to subtract 8 from both sides. 2x squared minus 8 equals 0. And if we were to graph this, we would see that it would cross the x-axis at positive 2 and negative 2. Alright, for the next one, again, to get m squared by itself, so that I can take a square root, I'm going to add 18 to both sides. But negative 18 plus 18 is just 0. Well, I can still take the square root of 0. It's just 0. So that will work. That just tells me that I have a quadratic equation that goes through the origin at 0. This last one's a little bit different. To get b squared by itself, again, I'm going to subtract 12 from both sides. 5 minus 12 is negative 7. So if I'm trying to get b by itself, I'm going to take a square root. And I do end up with b, but I get b equals an imaginary number because I can't take the square root of a negative number. So in this case, it's just no solution. So remember, graphically what this means, if I were to graph this, I would subtract 5 from both sides. I would get b squared plus 7 equals 0. Well, if I were to graph this, I would just end up with something above the x-axis that doesn't cross the x-axis. So that's why, remember, we say no real solution. Okay, for this one, again, no middle term, so it's a good one to take a square root. So if we're trying to get x squared by itself, we're going to divide by 4 on both sides. But this time, 9 divided by 4 doesn't simplify to a nice integer number, but that's okay, because I can still take the square root of a fraction. So I'm going to take the square root of x squared and the square root of 9 over 4. Square root of x squared is x. And then this I can actually break up. So the square root of 9 over 4 is the same thing as the square root of 9 over the square root of 4. So keeping in mind that I'm going to have a positive and a negative solution for these, the square root of 9 is 3 and the square root of 4 is 2. So now I have that x is equal to positive 3 over 2 and negative 3 over 2. So keep in mind that if this were on the graph, that would just mean that it's going to cross the x-axis at positive 1.5 and negative 1.5. Okay, so we can do a similar thing here. We want to get x squared by itself. So we're going to add 11 to both sides, and we get 3x squared equals 18. To get x squared by itself, we're going to divide by 3, and we get x squared equals 6. Now, we can still take the square root of both sides. The only difference here is that the square root of 6 is not a nice number because 6 isn't a perfect square. So I end up with x equals plus or minus the square root of 6. Now sometimes you're going to see your answer written that way, and that's fine. Other times you're going to see a decimal, so especially if it's asking you to round to the nearest hundredth, that means that you need to find the decimal answer. So in this case, the square root of 6 is positive 2.45 and negative 2.45. Okay, examples like this are where we really want to use the square root. So whenever you see x minus a number inside parentheses squared, taking the square root is going to be the easiest way to solve this. So to get that x minus 4 squared by itself, I'm still going to divide by 6. So I end up with x minus 4 squared equals 7. Now remember, what that means is we still have x minus 4 times x minus 4. So I can still take the square root of that. Square root of x minus 4 squared, it just undoes the square. So I'm left with x minus 4 equals plus or minus the square root of 7. So now to get x by itself, I'm going to add 4 to both sides. So I end up with x equals 4 plus or minus the square root of 7. Occasionally that will be the way you see the answer. They might also write x equals 4 plus the square root of 7 and x equals 4 minus the square root of 7. Now if they're asking us to round to the nearest hundredth, we can also find a decimal in this case. Okay, so in this case when we do 4 minus the square root of 7, we get 1.35. And when we do 4 plus the square root of 7, we get 6.65. You can actually type this in your calculator as well. You would have to subtract 42 from both sides, and you'd have to type it exactly as you see it. And you can still get these decimal approximations. But if the answer is written as a square root, so for example, if these are your option choices for your answers, you're probably going to have to do it by hand because it's going to be hard to figure out in the calculator how they got to these numbers. Now, if you did it in the calculator and you also found these decimals, you could go through and test the answers and see which ones end up being those same decimals. Okay, one more example. Look at function g. G of x equals 9x squared minus 16. Which set contains only the zeros of function g? Now, we actually did this on our calculator already, which will work just fine. But you can also do it by taking a square root. So remember, a quadratic function is going to have at most 2 zeros. So b and d don't make any sense because there's no way it could have 3 zeros. It's only going to cross the x-axis twice. So remember, to find a 0, I'm being asked to find the x-intercept. And we can think of this as y equals 9x squared minus 16. So to find the x-intercept, I'm going to make y 0. And now this becomes just like the other ones we've done in this section. So I'm going to add 16 to both sides. I get 9x squared. Then I'm going to divide by 9. So I get 16 over 9 equals x squared. And I can take the square root of both sides. Well, that becomes x equals plus or minus the square root of 16 over the square root of 9. Well, square root of 16 is 4 and the square root of 9 is 3. So now we have plus or minus 4 over 3. So both will work. Remember, in your calculator you got negative 1.33 and positive 1.33. So as long as you know that's the same thing, graphing will work just fine. But whenever there's no middle term, taking a square root is a very good way to solve quadratic equations. And that's it for this section.